Alright, picking up with concept 32.2, the history of animals spans more than 500 million years. So just a brief sort of geologic or biologic history of animals. Pretty obviously, the animal kingdom includes or contains a huge diversity of living species. So again, if you could compare, say, an elephant to a fruit fly to a human to a guinea pig, there's a huge variety of living animals. And as hard as it might be to believe, there's even a greater diversity of extinct ones. Some paleontologists estimate that over 99% of all animal species are extinct. So as many animals as you see around you in the world today, there are vast numbers of animals that have lived and gone extinct long before we were ever even around. The common ancestor of living animals may have lived between approximately 675 and 800 million years ago, but the divergence from fungi, who the other kingdom that we are most closely related to genetically, may have occurred even prior to that. This ancestor may have resembled modern canoflagellates, protists that are closest living relatives of animals. So if we were to look for perhaps the ancient common ancestor of all animals, it may resemble what we call a canoflagellate, a modern canoflagellate. The modern canoflagellate is kind of pictured here. It's not considered an animal, it is a eukaryote. But if we were to look at the lineage here where animals began, if we look at sponges, which we're going to look at sponges particularly in the next chapter, they have certain cells within their bodies that look very similar and are very similar to kinoflagellates. So the collar cells of a sponge are very similar to kinoflagellates, and sponges are basal animals. In other words, they are a type of animal or a group of animal that harkens back way back to the beginning of the formation of all animals. So there is some evidence that seems to point that our common ancestor of all living animals may be somewhat similar to this creature here. And that's because of some of the similarities we see between this creature and some of the parts of some very basic animals in the animal kingdom that are still around today, like sponges. So let's take a look back in time. Let's kind of step back through the ages, starting about anywhere from 1 billion to 500 million years ago. Some of the earliest examples of animal fossils that we have found, the early members of the animal fossil record, include the Ediacaran biota. The Ediacaran biota, which dates from about 500 million years ago. These soft-bodied multicellular eukaryotes have been found in Australia as well as other continents. And so this would be some of the first evidence of animal life, some of the first fossilized evidence. And remember, these would be soft-bodied creatures, so we don't have a great number of fossils of these creatures because it takes a very delicate process and a very unique process for a soft-bodied animal that doesn't have, say, a skeleton or teeth. For a soft-bodied creature to be fossilized is pretty rare. So we wouldn't have a lot of these fossils of these early creatures, and so they may have actually been around longer than the fossil record shows, but it would be very difficult to find such types of fossils. So these would be about 500 million years ago, the Ediacaran biota. Perhaps one of the most prominent areas of the fossil record for animals begins in the Paleozoic era. That would be anywhere from 500 million to about 250 million years ago with what we call the Cambrian explosion. And of course we say explosion is an analogy because in a fairly short period of time, we're talking about 10 million years. So when I say short, I only mean in the geological sense. In the fairly short amount of time, we have the appearance of a great number of variety of different species, and this would be for a couple of different reasons. So the Cambrian explosion marks the earliest fossil appearance of many major groups of living animals. So here in the Cambrian explosion in the Paleozoic era, we finally see fossils of creatures that are still around today, fossils of the ancient relatives of creatures that are still around today. And there are several reasons or hypotheses regarding the cause of the Cambrian explosion and the decline of the soft-bodied Ediacaran biota. One of those would be new predator-prey relationships, a rise in atmospheric oxygen, the evolution of Hox gene complex. All of these things would help usher in a new era of complexity of creatures. And plus you have a greater number of these creatures now have shells and hard body parts that fossilize, so the fossil record becomes much better for these creatures than it was for the earlier living creatures. Here you might have a Cambrian seascape with a huge variety of creatures that very bizarre looking to us today. Some of these creatures not around at all, of course, today, but some of these creatures are the early ancestors of animals that are still here with us today. Looking through the fossil record, we see that animal diversity continued to increase throughout the Paleozoic, but it was kind of a stop and start, 2 steps forward, 1 step back process punctuated by mass extinctions. Eventually, vertebrate fishes, similar to the fishes that we might have in the oceans today, emerged as the top predators in the oceans. And then the first evidence we have of animals beginning to make a major impact on land was about 460 million years ago. Fossils of arthropods such as centipedes, and we're going to discuss arthropods in great detail in the next chapter. So fossilized centipedes, millipedes, insects of various kinds began to show up about 460 million years ago, and these were fairly obviously land-dwelling creatures. Vertebrates, that would be creatures like us with a backbone, vertebrates finally make the transition to land about 360 million years ago, and they would be the amphibians, who are still around, and the amniotes, which became the reptiles, birds, and mammals that we have today. During the Mesozoic era, you had a continuation of this diversification, especially now that the animals were coming onto the land, and now you have both the land and the ocean continuing to diversify. This would have been anywhere from 250 to about 65 million years ago. Coral reefs emerged, becoming an important marine ecological niche for other organisms, and we'll talk about reefs and coral coming up in the next chapter. The ancestors of plesiosaurs were reptiles that returned to the water. So we have some examples of creatures that originally came from the water, of course. They moved onto land, and then we had some land creatures that were moving back into the water again. So much like we've discussed with whales, that their ancestors were land-dwelling creatures. During the Mesozoic era, dinosaurs were the dominant terrestrial vertebrates. At the end of the Mesozoic was the major die-out and extinction of most dinosaurs. And the first mammals also emerged during this Mesozoic period. They would have been small, primarily nocturnal insect eaters. They definitely were not the dominant creatures on the planet when dinosaurs ruled the earth. Flowering plants, angiosperms, like we've discussed in the previous chapters, and insects diversified as well, and you would have had, particularly at the middle or end period of the Mesozoic, a huge diversity of life. Much of this life not around anymore, but some of the life that we see around us today can be directly linked to that time period. The Cenozoic era brings us up to the modern day. This would have been about 65 million years ago to the present day. So the Cenozoic era marks basically the end of the dinosaurs. The beginning of the Cenozoic follows the mass extinction of both terrestrial and marine animals. Not only the dinosaurs, but a huge number of species were killed off or wiped out at the beginning of the Cenozoic era. These extinctions include the large non-flying dinosaurs and the marine reptiles. So the vast majority of all those creatures were killed off. We still have a few remnants of them, such as the blue jays and the mockingbirds in your front yard. Mammals increased in size. Once the dinosaurs, for the most part, were wiped away, that opened up a number of habitats and ecological niches, and mammals began to fill some of those vacancies and exploit some of those vacancies left behind by the dinosaurs. The global climate cooled and species adapted or perished. And then, of course, we know that in this time period there were various ice ages, periods of great cooling, and then warming again. In Africa, some species of primates adapted to a more open woodland and savanna habitat. They began, instead of walking on all fours and climbing trees, they began to walk upright. And then, of course, those particular primates would eventually develop into further species that became human beings, you and I. So the Cenozoic era brings us back up to present day, more or less. We're going to pause right there. That's a very brief overview of animals in general and the time scale of animals. And then we're going to pick back up with the next concept and talk about how we can divide animals basically based on something we call body plan, which is kind of the layout, kind of the set of traits that make up their body. So even in this vast variety of animals, there are only a few body plans that cover all the animals, and we'll look at that next. Let's take a break. We'll be right back.